Joey.
The integral from a to b of g of x.
Okay, yeah, so the area here is equal to the integral from a to b of g of x dx. I go put f of x. That's fine too. Okay, great. So again, right, it's the area underneath the curve g but above the x-axis and from a to b there. Cool. And so then what about this region? Let's go to, actually I'm going to go to Brandon. What do you say there, Brandon? What's the area of that region going to be?
Yes. You want me to take a guess?
I mean, yeah, educated guess, I hope.
The integral from a to b of f of x plus g of x.
Okay, so we want to take f's area here. We want to add to it.
Yeah. I got the integral from a to b of f of x minus g of x.
There you go, that's right. F of x minus g of x. With respect to x. We want to take this big area here, right, that's from like this curve, and we want to subtract off this kind of smaller area right here and be left with what's between those two. Exactly right, okay? And so you took the top curve essentially here, and you subtracted off the bottom curve, and you integrated still though from a to b. And that's exactly right. That yields that area there. Okay, questions on any of that? So it's just f minus the g there. We're all good there? Okay, so for the area of a region between two curves. So this is new now, right? We have not been finding the area between two curves. We've always been finding the area underneath a curve and above the x-axis. So x-axis to the curve there. Okay, so now we can find the distance or the area between two curves. Find these like very dynamic kind of strangely shaped regions that we otherwise would not have been able to find. I mean, it's pretty crazy, right? I mean, like this shape, you don't have a geometric formula for this shape, do you? Absolutely not, but you can still find it. Okay, it's pretty crazy, though. You can find that precise area of that weird-looking shape there. All right. So, if f and g are continuous on a closed interval ab, and g of x is less than or equal to f of x for all x in ab, so this just means that g is below f. All right. Then the area of the region bounded by the graphs of f and g and the vertical lines x equals a and x equals b is the integral from a to b of f of x minus g of x dx. Okay? Yes?
So that was like, I think just like another way of saying what the area of difference is.
Yep, essentially. The key things here, though, Anna, so again, this like these very mathematical definitions, you know, first of all, f and g have to be continuous, which kind of makes sense. You know, if we had like breaks or jumps or gaps or something like that, then that would be like, okay, well, how do we find the area in the first place? We need g, in this case, with the way our integral is written, g is less than or equal to f of x. If we flip this around, so if I said f was always less than or equal to g, then we want to flip this around too, and say g minus f. Okay, you always want to do your top curve minus your bottom curve. Okay, and that's true in general, even if your region is below the x-axis. Okay, so if I had, for example, Anna, like a graph here, and I had like a curve down here and like another curve like here, and I want to find the area of this region, I would do the top curve minus this bottom curve. Okay, it's different kind of, right, you're kind of reorienting yourselves here, but that's what you would want to do. You want to do the top curve here, which is actually this, it's on the top, right, it's above the other curve, and then minus this bottom curve here, even with a different orientation there. And then again, yeah, then the area of the region bounded by the graphs of f and g and the vertical lines x equals a and x equals b is this. So if you look up here, Anna, right, yeah, we've got this region, it's bounded by f, it's bounded by g, but it's also bounded by the vertical line x equals a and x equals b, right? So it's got four boundaries, f, g, x equals a, x equals b. Okay, so example 1 here asks us to find the area of the region bounded by the graphs of y equals x squared plus 2, y equals negative x equals 0, and x equals negative 1. So what might be a good idea here to do to kind of help ourselves out? We could sketch it, we could graph it. Let's use a graphing calculator. Let's use some technology. Okay. So let's try and see what we're looking at. Okay. So now if we look at these two curves graphed, it's not entirely obvious the region that we're talking about. Right? Whereas up here is a little more obvious. Okay, it's like this curve here and like this curve here together kind of like created a little region, and then we just wanted a piece of that region. Okay? But here it's not entirely clear. It's like, well, they don't really intersect or overlap in the same kind of way that these other curves did. So what's our region? Well, don't forget that our boundaries are more than just this curve and this curve. Right? We have 4 boundaries here. 4 of them. 4 fingers. Right? This curve, x equals 0, which is right here. Right? And the line x equals -1, which is right here. Okay, so our region, if I sketch that here for us real quick. This is a quick and dirty sketch. Okay. Here's 0, so that's another boundary line right there. And then -1, that's the vertical line right here. Okay, so our region, can you see it?
That space inside.
It's this space inside, right here. This is what we're talking about. Okay, that space. How do I know that? Because it is the only space that is bounded by all 4 of these things. That's the only space that's bounded by this curve, x equals 0, and x equals -1. Okay, so now we're going to set up our integral. So the area is going to equal, and this setup is huge because oftentimes in a free response question, obviously this would not be an entire free response question, but it might be like a part A or something like that. This setup right here is important because sometimes you get points for silly things like limits of integration. If you can identify the correct limits of integration, sometimes that's a point. Okay, the setup is sometimes a point too, just like putting in, the correct integrand. So it's very important we set this up correctly. All right. So we're going to integrate. We're going to find the area here. So we're going to integrate from what to what? Yeah. So I'm listing 0 is listed first, and then -1 is listed second. But technically, what should we really start with? We should integrate from -1 to 0.
So is it always implied to integrate from left to right?
Yeah, we want to end up with a positive area because again, we're talking about find the area of the region. So, and that's another thing I want to really be careful about, separating concepts, right? Integration. When I integrate a curve, that value can be positive or negative. If I'm trying to find the area of a region, though, I better end up with a positive value here. So that's why we definitely want to make sure we're integrating from left to right.
What if that region was below the x-axis?
It still would work out if you do, like I said before, the top curve minus the bottom curve. It will work out. It'll flip. The sign will flip. Yeah. Yep, it'll still work out. And we'll hopefully get to that in a little bit here. We'll see. Hopefully, we'll be able to see it exemplified. Okay, great. So, which of the 2 functions do I put first?
X squared plus 2.
Why x squared plus 2? It's on top. Yeah, it's above the other curve. So we'll subtract then -x. Please parentheses 2. Okay, so it's top curve in a quantity minus the quantity of the bottom curve. So this we can actually do by hand. So go ahead, let's do this. Oh, actually, I guess we can we can integrate that. So we integrate here. 11/6. Okay. Don't forget, on a free response question, right, you can leave arithmetic. So you could have stopped here. When you have a limit of integration that's 0, be very careful. Don't just assume, oh, my upper limit's 0, that means it'll be equal to 0. Not necessarily, right? If you have like e to the x in there, e to the 0 is really 1, and so be careful. When you are plugging in the 0 there, make sure you check, does this thing really equal 0 when I plug 0 in for each of these x's? In this case, yes. That's 0 plus 0 plus 0, so it's 0 for your upper limit. 11/6. All right? Now, how can we check this using our calculator?
Finite integral.
Okay, so math, and then what? Math, and then what? 9. Okay? And then in here, you have two options. You can type in x squared plus 2 minus negative x, comma x, comma negative 1, comma 0. Okay, which gives us 11/6. Alternatively, though, didn't we type these into y1 and y2? We did, right? So I could do, let's see here, I gotta remember which one I put it into, okay. So I could say vars, y bars, function y1 minus vars, y bars, function y2, comma, x, comma, negative 1, comma 0. Okay, that also works. This is going to be very helpful, folks, when you have more complicated functions you're typing in. I would really suggest you get used to kind of typing this kind of thing in. Be comfortable with this. Bars, y bars. Math, and then that gives you the arrow fraction, converts it to fraction for you. 11/6. It's convenient. Of course, Emma, if it's an irrational number, if it has like pi in it, for example, it's not going to convert, because it's got pi and stuff. It's going to be, if it's like a square root of 2 or something like that. But
It's like really crazy, I won't do it easy.
what's that? Some really crazy decimals? Yeah, or like even if it is a fraction, yeah, you're right. It will like kind of refuse. It'll. Right. Okay, let's try another one. More commonly, so you'll notice here we were given 4 boundaries, right? Top curve, bottom curve, left boundary, right boundary. Here again, top curve, bottom curve, left boundary, right boundary. Another more common way, or more common kind of problems we see involve area of a region bounded by 2 intersecting graphs, where you have to find the values of A and B, find those integrations. So if you look here, for example, it says find the area of a region bounded by these 2 graphs. Notice there's no like x equals and x equals. So when we go to set this up, we're not sure what our limits of integration are going to be here.
Find where they intersect.
We have to find where they intersect. Okay, exactly right. Now, we could use our calculators here, but let's try and do this without a calculator now. Okay? So, all right, let me ask one question. How could I determine which of these curves is on top and which of these curves is on the bottom? Say again?
You can plug in a couple points.
Plug in a couple points to try and see. Ooh, actually,
Well, you might have one part that goes up and one,
yeah, exactly. So what we need to do instead is figure out where they intersect first, I think.
Yeah, and then plug in
Yeah.
in that area.
Right. Okay. Well, they intersect in more than one spot. Well, let's talk about that in a second here. So how can I determine when these 2 things intersect?
Send them equal to each other.
Set them equal to each other, right? 2 things intersect if they are equal to each other at the same x value. So I'll say x equals 2 minus x squared. How should we go about solving something like this? Let's go to someone that doesn't want to be called on, maybe. Ryan, what do you say? How do we solve something like this?
So, I'm making it.
Ryan's eating a bunch of solutions right now.
So, I'm just kind of like simplifying and get all the x's on the same
Yes,
side first.
get it equal to 0, right? So move everything over to one side, so you get x squared plus x minus 2 equals 0. Very good, because now what are we going to do here, Ryan?
Factor?
Factor! Does it factor?
Yeah.
Connor says yes.
I agree.
Yeah, it does.
What's that? How does it factor?
X multiplies to -2, x minus 1, x minus 1. No, x plus 1.
Nope.
Good save.
Wait, no, x minus 1, x plus 2.
There you go.
Good save,
Okay.
Good save.
And then x equals 1 and x equals negative.
So yeah, x equals 1 and x equals -2. So how many regions are we talking about here? Yeah, there's only going to be one region. It's going to be between these two values. Okay, you can kind of imagine that too, because what's this a graph of? A parabola, and this is a graph of what? A line. So it's just going to, create. You can kind of maybe imagine what that region is going to look like. It's a line intersecting a parabola, so it creates a region there. Here are limits of integration. So to find the area, we're
So
going
you have
to
find which one's up top.
yeah. So we'll get to that. Right. So we have to integrate from what to what? -2 to 1 of the top curve minus the bottom curve. Which one of these is on top?
Yeah, plug in.
Someone may be able to figure it out just by logic, just thinking about it. But we can also figure it out by plugging it in. What would be a good test value here? Would 5 be a good test value here?
No, you want it in between your, you want to test in between your left and right.
Right, we're only interested in x values that are between -2 and 1. And so we want to pick an x value between -2 and 1 and evaluate it in both functions. So a good test value would be 0. So f of 0 is 2. G of 0 is 0. So which curve's on top? F is on top. It's got the higher y value at the same point. So we're going to do 2 minus x squared, that quantity, minus x, that quantity. Okay, let's check ourselves and make sure we did this right. So go to the calculator. We'll graph 2 minus x squared, and then x. And there it is. Okay. So there's our region, right? There's -2, there's 1. You can see that little region right in there. I'll zoom into the skosh. There you go. Look at that funky thing. But isn't that crazy? We can find the area of that. Before this, you had no idea. You couldn't use geometry to solve this. This is not like a semicircle or even like some fraction of a circle. It is no geometric shape. But because of calculus, we can now find the area of that crazy looking region there.
Newton have figured that out?
Maybe, yeah. I don't know. I think he did more like differentials, and like derivatives and stuff like that. I don't know if he did too much with the integral stuff.
Who did it?
I think Riemann actually,
Yeah.
the guy for the sums and stuff. But I'm not sure. I think
Did you have to take class?
Leibniz did too. Well, the history of calculus, that's not as big of a deal. It's just like, what's that? No, that's what I'm saying. I'm sure it exists somewhere, but anywho, we won't bother about actually doing this by hand. We'll go ahead and just do this with the calculator here. So, Math 9. Bars, y bars, function y1, minus bars, y bars, function y2, comma x, comma -2, comma 1, 4.5. How nice is that? That crazy region is 4.5. Okay. 4.5 square units. All right. Why don't you guys go ahead and see what you come up with for this one. Okay, try it. Try doing the same thing we did before. So in other words, try doing this by hand without a calculator. Get up to the integral setup. Okay, so try everything without a calculator up into the integral, evaluating the integral itself, and then we can talk about that. Okay, so go ahead and try at least set up the integral. Okay, so get to the point where you have the integral set up, no calculator. Yep. Yep, right at pass.
plug in points, should we like write a sentence saying f is greater or g is higher? Or...
I don't think you need to because it'll be implied. The idea is that you're setting up the integral such that you put the higher function minus the lower function. So it'll be like, when you set it up the correct way, it'll be indicating what you want to indicate. But you still want to show your work for testing, I guess.
I made it last night, but I left it at home.
Figures. There you go.
Yeah, I know, right?
That's good you found it, though.
Yeah. I just hope I remember it tomorrow.
Yeah.
Mr. Wade,
Yes.
how do you get the 2 points of integration of the...
The limits of integration?
Yes.
Well, you're trying, you want to set the two functions equal, because the idea is you want to find that it's a region that's bounded by those two curves. So you want to know when those two curves meet,
Oh, okay.
right? So when they're equal to one another.
I can equal.
We didn't finish number 2. No, I didn't. I did. He said start the next one, not start number 2.
Do you have some natural up in here? Oh, yeah, that far, never mind.
Why are you doing it by hand?
You said you're supposed to do it by hand.
Up until you get the integral.
Oh. Never mind.
So the extra
But yes, I think I would do that.
There were a couple of broken back. They didn't expand So you get my hand. You see your hand still like try to eat the little moles in front of this off your hand. And you think it's good. So they like just poke out with it. Because then it's so fun.
No, what?
Domesticated
You picked a point
between these two tricks.
X value.
You tell me that we did it, all good.
No, I should plug 0 and equal those functions. Whichever function gives you a higher value, the one that's on top.
What'd you get?
How we doing?
10.37?
Yeah. Now what? You don't know?
Just do it every day.
I think.
That's what I got. That's what I got.
The fish have instinct.
What do you mean multiply by five?
I mean, I guess you could train them, you have to, like, the memory
What?
stuff, you have to, like,
My spoon.
they just do it without even knowing
My
why.
spoon.
That was what?
You're gonna be-
God, help
No.
us all.
My spoon.
I went to.
Is that right?
Read it last night. The McKinney.
You ignored though, and you
I
said.
showed her.
Yeah.
Showed her what?
The dominant.
You did? Yeah. What'd you
That was
say?
weird.
So like, why am I talking to this guy now?
I don't know why I like
Oh, we're done.
correct, yes.
Are you guys a thing now?
You don't have the same, well, extra weight.
Okay.
I didn't just like
Oh, wait, let me check on this one.
show it to her.
How do you mean?
We got different.
Like I wasn't just like randomly talking to her about something else, and then I was like, oh, you need to watch this video, and then like pulled it up and showed it to her.
That's what I would have done.
No.
Yeah, you wrote, oh, okay, yeah, so you can't, so,
Boom.
what you can't, it's,
How do
so
I
you
come
try to
up with
add
something?
5 over here to -2 from the -7, but it's a
No,
quantity
she was like-
there, so, yeah, that's okay.
She showed me
So,
this
yeah,
video.
you wanna multiply that x plus 3 over.
Which was really funny.
Okay,
And she's like, yo, I guarantee you like.
here's what we should have.
Weirder
Boom.
Video.
You were like,
And I was like, oh yeah.
So your limits are from -2 to 4. Okay, limits are from -2 to 4. F of 0. So I picked 0. 0 is between those two values there. We got to figure out which curve's on top, right? Once you get those limits of integration, you still got to figure out which curve is on top. Okay, f of 0 is negative 7/3, g of 0 is negative 5. Which one's bigger? Negative 7/3 is bigger. It's less negative. So, it's f minus g. Okay, when you plug it in there. And I know I didn't ask you guys to integrate this, but we could. What would we do to integrate this piece?
You have to bring out the negative 7 and then split up the, with the natural log.
It would be a natural log, right? Integral of 1 over x plus 3, that'd be like a u substitution, let u equal x plus 3, du would just be dx, and it should be negative 7 times the natural log of x plus 3 there. And then these two are easy enough to integrate because they're separated by the subtraction sign there. Okay, we won't do that though. We'll just type this in. Let's see here. So negative 7 divided by x plus 3, and then the quantity x minus 5. So math 9. Whoop. Math 9. So we want to find bars y bars function y1 minus bars y bars function y2. Okay, and you should end up with 10.379 approximately.
Do you truncate, Ryan?
What?
Do you truncate?
Yes.
Okay, that one, I'll give you that one.
So once we did this, Emma, what do these give us? The endpoints, the limits of integration, right? Okay, but then how do I know which order to subtract here? All the ones we've done so far have been f minus g, but it doesn't have to be f minus g. It's only been f minus g in the past because in the past f was greater than or equal to g, and g is always less than or equal to f. We need to always make sure we're doing top curve minus bottom curve. We've got to figure out which curve's on top. How do we do that? We pick a number between these two and figure out which one gives us the highest value. That's the top curve, lowest value, bottom curve. Okay, there it is, 10.379. Question on that? All right, cool. We're going to do some more here. Let's try some more. Some more. Samoa.
Will this become our homework assignment?
We'll have homework related to this, yes. Yee.
Yeah.
All right, so Caleb asked a really good question. He's regretting it now, maybe. Maybe not. Caleb asked, what if they intersect at more than one point? What do we do? He didn't ask it that dramatically. Well, let's talk about that. So, find the area.
Is this on our notebooks now?
Yeah, you want to, I don't have I didn't print this out because I didn't feel like it was worthwhile printing it out.
Sine cosine curve.
Oh, no, I'm not being that mean to you yet.
Keyword.
Wait till we take these regions and we rotate them three-dimensionally to create a solid.
Stop.
Wait, really?
Uh-huh.
Nice.
Can we make donuts?
We can. They're called torus in T-O-R-U-S in math, but yes, donuts.
Can we do donuts?
Delicious, delicious donuts.
Oh, we can do donuts.
To graphic, can we go to graphics? Can we go out in the parking lot and do donuts?
But those aren't three-dimensional, Ryan.
Yeah, they are.
If you do it enough times, you'll be three-dimensional.
Maybe we can eat some donuts, right, for research sake. Yes, 3x cubed minus x squared minus 10x, and g of x equals negative x squared plus 2x. Oh, nice. Okay, this actually will work out. So, all right, we've got two curves. We want to find the area of the region between them. What should we do?
Set them equal to each other.
We need to set them equal to each other, right, to see where they intersect, just like before. Okay, so we're going to find the area of this region that's bounded between the graphs of these two functions. So we'll set them equal, like we did in the past, to find those points of intersection. So that's going to equal negative x squared plus 2x. Bless you. Okay, now what should we do? Well, if we add the x squared over, the x squareds will cancel. And I'll subtract the 2x over, so I'm left with 3x cubed minus 12x equals 0. Am I going too fast for anybody? We all okay? All good? All good? Zoom in a million times. I saw you squinting there, Anna, so. What was your question, though? Pause. Freeze. Unfreeze.
Stop. Hammer time.
Time in, time out. Time out, time in.
I see why Caleb posed this question.
It is a good question. Okay, so far so good, Anna? Can I move on? Alright, at this point, what should we do? How do I solve this? Add 12x over and divide both sides by 12x? No, factor, right? Yeah, we don't want to add 12x over. We don't want to divide both sides by 12x. No. Factor, factor, factor. So we'll pull out a greatest common factor of 3x.
And it works out nicely.
And so, yeah, that x squared minus 4 is a difference of squares. That does factor, right, to x minus 2x plus 2. And so we have x equals 0, x equals 2, x equals negative 2. Or in order, x equals negative 2, x equals 0, x equals 2. It might be more helpful to have it in order here. So we have 3 points of intersection. So that means how many regions are we dealing with? No, that's right. Yeah, two regions.
Let me look at this.
Okay, 2 regions.
Don't spoil it, Ryan.
Graph.
Oh, I think I
Okay. We have 2 regions here.
Aw.
So, because we have 2 regions, we're probably going to have to write 2 integrals. Not necessarily, but it might not be a bad idea to write 2 integrals here. So the first integral we'll write is the area from what to what?
It's going to be from -2 to 0.
Negative 2 to 0. Those are our first 2 kind of points. And we have to figure out, okay, in this area, between these 2 points, which curve is on top, which curve is on the bottom? Well, we can evaluate it like x equals negative 1, for example. So like f of negative 1 and g of negative 1. So that's your f of negative 1 is going to be negative 3 minus 1 plus 10. G of negative 1 is going to be negative 1 minus 2. So we get 6 and negative 3. Okay. So that means when I go to write my integral here, what function should be first? Yes, f, because f is the higher value in that interval. So it's going to be 3x cubed minus x squared minus 10x, that quantity, minus negative x squared plus 2x.
You just assume that it switches on the interval.
Not necessarily. It doesn't have to switch. In this case it will,
Yeah.
but it doesn't have to. Okay. So it's that plus, I'm going to add that integral there. Okay, so the next integral is going to go from what to what? Okay, plus the integral from 0 to 2. And now we assume, oh, they must switch. And they most likely will switch. 90% of the time they'll switch, but we should still check. So let's check f of positive 1 and g of positive 1. And so let's see, we get 3 minus 1 minus 10 and negative 1 plus 2. So I get 1 there and then negative 12 there. So sure enough, they do switch. And so then it's negative x squared plus 2x dx minus 3x cubed minus x squared minus 10x
So
dx. Yes, question?
when would they not switch?
I'm trying to think here. I think if there were some absolute values involved, potentially, it could be.
Or like what if it like touched?
Or it could be like even a cube or a quadratic or a quartic, maybe something like that. It could work out. Let me just, I probably won't be able to come up with something off the top of my head, but
24. Yeah, buddy, I got that too. That's pretty.
Yeah. We'll see, if I see an example, I'll try and find one and point it out to you. Okay?
That's crazy how that works out.
Mm-hmm.
My immediate thought is something like this. If we have like a region like that, and like maybe a parabola comes down and just like kisses it right there, and comes back up. So there's technically like two regions, but then symmetrically they're like gonna be the same and stuff. So anywho, so how do we do this in our calculator? Well, let me show you. If we type again using our y1 3x cubed minus x squared minus 10x, and we use g of x negative x squared plus 2x. Okay, so we type f in our y1, g into our y2. Let me show how easy this is. Math 9. Okay, so we're going to integrate y1 minus y2, comma x, oh no, comma 0, it's negative 2 to 0, comma x, I think, right? No, it's x and then 0. I just messed that up. Okay, so there's my first integration.
Negative 2 to 0, not 0.
Oh, right, yeah, sorry, negative 2 to 0, thank you. Okay, so y1 minus y2, f minus g, with respect to x from negative 2 to 0, and then plus, you put a little addition there, that's right. Math 9, you can add the next integral. Bars, y bars, function, y2, we're switching them up, right? It's y2 minus y1 in this case. Comma x, comma 0, comma 2. So now we're going from 0 to 2. And the calculator chokes a little bit and says 24 is the answer. Is that not what?
No, I got that.
You got it? Okay.
I was saying, wait, what's that?
Okay.
Does Kate have CAPTCHA now?
CAPTCHA?
Yeah. Look.
Okay, so 24 is your final answer there. All right. By the way, folks, if you're on a free response question, you don't actually have to write out the function. You may use the function name here. So, for example, if you're like hurting for time, okay, if you want to like speed things up a little bit, instead of writing out the actual function itself, you may write just negative 2 to 0 of f of x minus g of x dx plus and then g of x minus f of x dx. You may write that out because they've already been established as f and g. Okay.